The purpose of this video is to demonstrate the differences between developing an EVM smart contract for Ethereum blockchains and developing a substrate pallet for Polkadot blockchains. So fortunately, I have a smart contract that has been ported to a substrate pallet almost exactly. So this makes for a great comparison. So of course, one of the major differences is if you're writing a smart contract for Ethereum, it's going to be written in Solidity or Viper and then compiled to EVM bytecode. Whereas if you are writing a substrate pallet, so you're going to be writing it in Rust. Okay, so one of the major differences is that with a smart contract, it is sandboxed. So what that means is that if we look at one of these functions, so no matter what this function does, it cannot actually break the blockchain that it's running on. It cannot interfere with the state of other contracts. So this gives it a lot of safety. Whereas if you have a substrate pallet, then that's not true at all. So a substrate pallet can actually, it can change anything. So that's part of the reason it has such good performance, because it essentially has root access to the blockchain. Okay, so another big difference is how transaction fees are calculated. So with a Solidity smart contract, it's compiled to EVM, and then there's a system for counting how much gas each EVM instruction uses, and that is how the price of the transaction is calculated. And of course, this can add a lot of expense because it takes a lot more processing power to actually interpret the EVM bytecode while ensuring that gas is not used. So if you compare this to a substrate pallet, it has a benchmarking system. And the great thing about this is that it doesn't require the monitoring of resources as the transaction is being processed. So another big difference is if you're deploying an EVM smart contract, so as long as you have enough funds, enough ETH to deploy the smart contract, you can deploy it. No one can stop you, so that's permissionless. Whereas if you have a substrate pallet, then this can only be deployed via chain governance. So there is a mechanism has to be gone through, and this is why a substrate pallet essentially has root access to the blockchain, because it can only be deployed via the governance mechanism. And actually, you can deploy smart contract pallets to a substrate blockchain. And once you've done this, then you can deploy permissionless smart contracts. And of course, if you have a Solidity smart contract, then normally there's no means to upgrade it. So you just you compile it to EVM bytecode, you deploy that to the blockchain, and it's not going to change unless you actually implement a system for upgrading the smart contract. But on Ethereum, this has to be actually written. This has to be part of the design of the smart contract. So that adds a lot of complexity, and that can be a source of insecurity. Whereas with Substrate, because it has this upgradable runtime, so the runtime for the blockchain is actually stored in state, and this means that any pallet or any smart contract on a substrate blockchain can be upgraded via the governance mechanism. Okay, so we're going to have a little look into the code, at a little look at some of the differences. So in Solidity, you have what's known as modifiers. So here, if you want to trust an account, it is performing a check is not sender. So the idea being that it's not permitted to trust yourself. It's assumed that you already trust yourself. And if we look at the equivalent function in the substrate palette, so we can see that we actually make the check here. So there's no modifiers. We can just we can implement the check in line, and then if necessary, we can throw an error. Okay, another big difference is on Ethereum, you have this concept of each call into a smart contract is atomic. So if this function is called, then it will either execute in its entirety and make modifications to state and make calls to other smart contracts, or it will not execute at all. So if a transaction is if an exception is thrown, then it will get reverted. So any changes made to the blockchain state will be reverted. And this is one of the reasons why transactions are more expensive on EVM blockchains. So if we make the comparison to a substrate pallet, so you'll notice I have this line here. So this is the point of no return. So before that line, we don't make any writes to the database. And then after that line, we make it a database write, and we have to make sure that we don't exit the function early after that. Once we make our first database write, we have to make sure that we make the other two, otherwise the database will be inconsistent. So again, this is another reason why transactions are cheaper on a substrate pallet, but it means you do have to do the extra work in your code to make sure that if there is an error, that it's not going to leave the database in an inconsistent state. Okay, another difference is in Solidity, in EVM, you have this concept of indexed event parameters. So this means that if you emit an event in your smart contract, then there is a means to actually search for this. So this will be indexed by full nodes, and then if you query the full node, you can ask for a little search to happen, and the full node will be able to find your events based on your query parameters. But this is actually kind of a bad idea, because it's not compatible with light clients. So if we look at the equivalent in our substrate palette, so we have the event, but there's no means to simply index it, because of course if your blockchain functionality, if it can't be accessed via light client, then it's not really fully decentralized. And so what you should really be doing is, instead of using indexed event parameters, you should either be using other form of on-chain indexing in state, or in Substrate you can actually have what's called an off-chain worker, and then you can do much more sophisticated indexing specifically for your use case. So instead of having the whole blockchain indexing all the events for all of the apps that will potentially be querying it, your node can specifically index what is required for that application. So the last thing I'm going to talk about is the RPCs. So on Ethereum, in Solidity, of course, you can write these getter functions. So instead of just simply getting a single value from state, you can implement code. So this will be this is typically not part of a transaction. So you can simply ask the node to run this code and perform the various reads from blockchain state, do some processing, and return the answer to you, which of course is fantastic and very simple to implement on in Solidity, because it's just the same as any other function. Unfortunately, on Substrate at the moment, it's quite a lot more complicated. So if we scroll down and find our getters, so it's implemented here, so that looks fairly straightforward. Unfortunately, you also have to create some other sub pallets. So you have to create a RPC sub pallet, and then you declare your methods here, and then also down here. And then you have to create another palette, which is the runtime API palette, where you again declare your RPC methods. And then also in your JavaScript, you also have to declare the method signatures again. So that's something that Substrate is not doing very well at the moment. So hopefully a lot of this boilerplate code can be removed in future. So I hope you found this video helpful, and I'm going to be bringing some more Substrate development videos very soon. Thanks very much.